did have a kind of a lot of feedback to give people as I was grading those quizzes. I thought they went generally okay. But as we go towards that test, which will be next week on, what's the 17th? Thursday? Yeah, Thursday. St. Patty's Day. What a lovely present for you all. That test, you're gonna want feedback on how you're writing these things down before you take that test. Unless you've been like really like super understanding all of the notes, you're like, I got the notation, I'm feeling it, feeling good. You're going to want some feedback as we go. There were a lot of things about how we were writing things down that I tried to give feedback on, even if I didn't take off points on the quiz that I will be pickier on the test. So please, 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 if you didn't take that quiz, make it a priority. Try to come in because you're going to want that feedback. Also, problem set, that guy is due on Tuesday of next week. I'm going to try to build in about 20 minutes of work time, but if you haven't opened it yet, you're not going to be able to get it done in 20 minutes. So please make sure you're starting to work on that. Instead of doing a notes check today with today's alternating series test, we're going to literally do the 2 questions from the problem set that are alternating series test. This test, yeah, what's word on the street about this test? Anyone talking about it?
No.
Oh, okay. Alternating series test is a relatively simple test as far as our series tests go. It really just involves writing the same sentence every time. So you'll probably like that. So we're also going to do a little bit of extras with alternating series, talking about error bound, some other stuff. It will be, in a word, thrilling. So as I pass out your notes, if you would like, I accidentally gave this one away. So this pink one is 2 pounds. What's the purple one? I'm going to pass these out and then I'll get some guesses.
I would say D.
I know, it's so embarrassing. Give it back to when it's all the way cold water, that's pretty heavy. It's really heavy. You could like curl it. This is pretty heavy. Yeah, I think you had one. No, mine's like only half. Yeah. And you're gonna hold. Yeah, I was that. Oh, no. All right.
All right.
That's crazy. Everyone's like, everybody's fine.
All right, I'm going to guess who's
I second that.
Yeah. I second that. I third that.
Because
I
it's
keep
hot.
that.
Either 5 or 8. I think 5.
All right.
4. Oh, no one makes 4.
Yes, I have a 4
Okay,
pound
well.
All right. Noah.
Oh,
I haven't seen this one yet.
Nobody better keep 3. I love when
Henry?
Maddie.
All right. Now Trut.
5. You just like Charlotte.
All right. Ashley.
3. You literally look like a Lego, dude. Like a man.
7.5.
I mean, if I can see what
Can you move your entire hairline? Yeah, that's what I was talking about. It looks like a Lego piece.
Alright, I can't be the only one.
I feel like it is. That's not impressive. Everyone. No, it's not.
All right. Anyone else? Anyone else?
Hey guys. Hey.
I mean, you're not wrong.
Who's got it?
Wow! Did anyone guess? Oh, yeah, you guys did.
Oh,
That's bigger.
wow, that's a good guess.
All right. So, all right. So. That was probably really loud.
Alright, you guys ready for alternating series test?
All right. I think this test in and of itself is the easiest to find and close to the easiest to do. It does require us to be relatively formal in how we write things down. So today we're going to talk about what we can write down as our actual work, what we can write down as our scratch work. We're going to talk a lot about notation. So alternating series says, what does the word alternating make you think of? Good. So our terms are going to alternate between positive and negative. Doesn't matter which one they start with. Now, one easy way to do that, as far as like what it would look like in the series, what do you think in here is making it alternate back and forth?
The power.
Yep, this guy, and specifically the -1 to that power. Think of if you plug in like regular values, integer values to that. If I plug in 1 to here, I'm going to get -1 squared is +1. 2, -1 cubed is -1. 3, -1 to the 4th is +1. So sometimes I'll call those pieces the -1 to the n or -1 to the n plus 1. I'm not sure if this is an official term, but sometimes I'll call these alternators because it's the thing that makes it alternate. And I'm not sure if I'm convinced on that OR. So if you'd like to fight me on the spelling, I will probably fall pretty quickly. So what does this alternating series test say? We're going to have 3 very specific conditions. Why did I highlight the whole thing? What a dweeb. Yes. All right. So one of the reasons that alternating series are really easy to find is generally there are more creative ways to make an alternator, which we're going to see later today. But generally, we're looking for something like that. It's pretty in your face of like, hey, I am alternating. Look at me. So then we're going to look for 3 conditions. The first one do we alternate? So condition 1, done. Condition 2 can be called a couple of things. Decrease in magnitude is one of those things. But notice here, we want the n plus 1th term to be less than or equal to the nth term. And when I talk about these terms, I'm talking without the alternator. So if I disregard sign, do these things get smaller as I go? Condition number 2. Condition number 3, eventually we need to get those things to get so small that they're headed to 0. Essentially, we need it to not fail nth term test. So if we can say those 3 conditions are true, we converge by alternating series test. Now, do you see anything about diverging by alternating series test? No. So this is not something we're going to say. We're not going to be like, oh, this diverges by alternating series test, only for convergence. Now, if this one's broken, so if the limit doesn't go to 0, what test do you think we're going to use? We're going to use nth term. So generally, that's the one that fails if we're thinking alternating series test. So generally, that's the one we would use because usually the limit is the part that's going to fail. Now, this test is just really straight up not that interesting to do. So we're only going to do a couple of them, and then we're going to move on to different pieces of this that are a little bit more interesting. If you're looking forward to break already, we're going to break after the first page. By like first page, front and back. Sorry. I phrased that wrong. Phrase it wrong. All right. Jeez. 5 problems. Not going to take that long. At the end of class today, I'm going to prove 2 different numbers equal each other.
Okay. Oh wait, Miss Hefty, I saw this one thing about how 2 different shapes equal each other.
It's pretty. It was it topology.
It was just a circle and a square.
There's something called topology where you can say that a coffee cup and a donut are the same shape.
I I mean, I guess I can maybe.
Just one hole, essentially. All right, so this guy, so I'm gonna do two sets of work here, two very separate sets of work that I'm going to label. One of them would get me points, one of them would not get me points. This one I'm gonna label scratch work, aka the one that would not get me points. I'm gonna use some abbreviations here that are not legal in like the actual way I do this. But let's look at this series. So this is the first one we're doing. Let's look at this series. Let's look at the terms. So in your noggin, we're going to stare at that series, and I want you to find me the first term. What number would I plug in to find the first term? I'm doing that because it says n equals 1 at the bottom. So focus. When you think you've got it, just give a nice thumbs up. If you're proud of yourself, way up here. If you're like kind of proud here. If you just want me to know, right here. What is the first term of this series? Didn't show up yesterday or today. All right, what's the first term? 1. So the negative 1 to the now power of 2 is positive. 1 over 1 is 1. What is the second term? I like negative. What about the 1 over n? 1/2. All right. What about the next term? Plus 1/3 is Gerben. I agree. Next one, if you're not Gerben. 1 what? 4th. All right. Use your pattern making skills now. What do you think is next?
1/5.
Next one?
-1/6.
Oop, not -6. 1/6. And I'm just going to write plus ... because I kind of get it. All right. So we are looking for 3 conditions every time. Does anyone remember the first one? All right. Do these alternate? Yes. Notice I go positive term, negative term, positive term, negative term, positive term, negative term, so on. All right. So notice I'm using an abbreviation because it's my scratch work. I can do whatever I want. What was the next one? All right. I'm going to write something here that's not going to go in our official work. Deck in mag. That's how I write it on my scratch work. That is not going in my official work, though. My second block got really mad because I called out a specific person who I used to fight about that with. Trevor Kapoff, if anyone knows him. Because he wanted to write deck in mag, but that doesn't mean anything. All right. So if we disregard the signs, so when I say magnitude, think of just if all these numbers were positive, are they decreasing? So 1, 1/2, 1/3, 1/4, 1/5. Yeah, so magnitude, think of like speed is the magnitude of velocity. You're just talking about like regardless of sign. All right, what was the last one? Limit of 0. So when I look at this limit, I think the mathematical notation is short enough. I am just looking at the thing without the alternator. So just the 1 over n. Is that going to 0?
Yeah.
What? Because n's approaching infinity, my number of terms.
Oh, keep adding forever.
Yep, so just matching this guy right here.
Yes.
All right, does this go to 0?
Yes.
Yeah, because I'm plugging in, I get 1 over infinity. Infinity is so huge that 1 over that is pushing this towards 0. So I have checked, either you can check these in your brain if you want. I'm just checking them in scratch work. Let's talk about the official answer. The nice part about this official answer, you can use it every time, and there's literally only one part that will change based on what series you're doing if this will work. So I'm going to say, since my terms, what did alt stand for? Alternate. Decrease, wow, full words, in magnitude. And you could write the word and if you would like, but an ampersand is fine if you're feeling fancy. The limit, Miss Shetty taught me, because I used to not be able to. The limit as n approaches infinity of 1 over n equals 0. My series does what? Converges by your science test, AST, or alternating series test. Yes. All right, so if you're noticing, this sentence is going to change not a lot depending on the series. So if this test works, what's the only thing that I would have to change to match the series that I'm working with? The limit. So really, you can memorize this sentence, and this is the only thing that really has to change if you're doing this test and it works.
So like if you put that down on a test, but you
Yeah.
get the thing, would you get points for the actual sentence? Or no, because you
Didn't-
answer right.
Well, if this doesn't work for this, then
Okay.
so the test has to work. Yeah. Depends on how egregious. If they can understand you, then you're probably fine. Which word are you worried about? Oh, okay.
Like when you like miss, like forget a letter.
No, you're fine. You're fine. It's not a spelling test. All right, Rashad. Yeah. So Rashad's asking a good question. Could you skip the scratch work? By all means, yes. And that scratch work, you could be checking that in your head. You could be doing all of that to the side. I like to do it just in case things don't work as I go. So speaking of not working, let's look at this one. So I'm going to do my scratch work because I'm checking these things. No, I'm just labeling it for explicit notes.
The thing that we do with the limit is you said it's excluding the alternators.
All right, so let's start with, does this series alternate?
Yeah.
All right, Ashley says yes. Does anyone else say yes? Does this alternate? How can I know without checking all the terms? Look for the alternator. So do I see a -1 to the n or -1 to the n plus 1? Yeah, and that's going to change if I plug in 1, then 2, then 3, then 4. Yeah. So this test should be pretty easy to find. If you see a -1 to the n or -1 to the n plus 1, you're like, oh, I see you. All right. What was the next thing? Decrease in magnitude. Do you think that's true? If I plug in bigger and bigger values of n, do you think this fraction will get smaller and smaller?
Yeah.
I think so. That 2n is bigger than that n on the top. So let's keep going. I'm going to do the limit as n approaches infinity of the thing without the alternator in it. So I'm going to do n over 2n minus 1. Thoughts on this limit as I go to get my computer charger?
The bottom is bigger than the top.
Wait, why don't you put the alternator in there?
It makes the limit a little bit more confusing. So I'll talk about it in a second when we get a value for
I'm
this.
gonna just make the limit 1.
Oh, what'd you say?
I said 1/2.
Does anyone like Ash's 1/2 for this limit? All right, I like that because we have the same power of n top and bottom. So we're looking at the ratio of our coefficients. So we're looking at 1 over 2, which is 1/2. Now, the reason we disregard the alternator is that would kind of, as we approach infinity, make this oscillate between 1/2 and -1/2 if we think about like actually reaching infinity. So this is a little bit easier to like think about and talk about. Either way, why do I care about the number 1/2? It's not 0. So what does this series do?
It doesn't diverge.
All right, it does diverge. I can't say by alternating series test. So what I'm going to say is by nth term test. All right. And it's okay that I'm doing this nth term test without the alternating series part in it, without the -1 to the n in it. If you put that -1 to the n in your limit, you would just have to say that this limit does not exist. It wouldn't equal a certain number because it's kind of oscillating back and forth. But that would be fine as an answer. All right, so as you can imagine, that's kind of as interesting as this test gets because we can pretty easily see if something alternates. We're looking for that -1 to the n. We've already talked about being able to see if something decreases by plugging in bigger and bigger things. We've taken about 3 million limits as n approaches infinity at this point, and now we have this sentence to work off of. So as we go through the rest of class, we're going to be talking about different types of ways to use alternating series and different things that have to do with alternating series besides just converges by alternating series tests. I will say the stuff that we're going to do after this point and before our break needs very specific instructions. So if you have looked at your problem set, that first set of problems where it's like just 4 on a page in a chart, this would be all I need to do for that type of question. There is a question towards the back of your problem set, and I'll look at it in a second, where the directions change to this, where it says determine the absolute or conditional convergence. So there actually is an interesting thing that happens based on this alternating series test. So I'm going to look at this one for one more second. Does this series right here look like any other series that we've done? Maybe if I cover this part up. It looks a lot like the harmonic, right? So this is actually called the alternating harmonic, not too creative a name. And notice that the alternating harmonic converged. What did the regular harmonic do? Diverged. So there's this group of functions that are what's called conditionally convergent, where the condition that they converge is that they are alternating. So we actually get different strengths of convergence here. So we're going to talk about those before we hit our break. So here's the kind of 3 situations you could be in. First situation isn't really written down. It's just if you diverge, you just straight diverge. There's not any like types of divergence. You diverge, you're done. If something converges, I have 2 types of convergence, kind of 2 strengths of convergence. I can be absolutely convergent if that absolute value converges. So essentially, if I drop the alternator, that's what the absolute value bars would do, would drop the positives and negatives. If I drop those positives and negatives and I still converge, I would be absolutely convergent. It's a little bit stronger. If something's like the alternating harmonic, where it needs the alternator to converge, then it would be called conditionally convergent. I like to think of that as it has the condition that it needs the alternator to converge. One kind of interesting conclusion is if you drop the alternator and something converges, then the original thing with the alternator has to converge, because absolute convergence is like a stronger version of convergence. So now that I've said the word converge about 20 times, let's try a couple of these problems. So the reason these get a little annoying is we end up having to do multiple tests within one test. So here, when we do this, we're going to first establish, do I converge at all? Then if I do, I have to do a second series test. So let's start. So I see an alternator. Do you?
Yes, I do.
Yeah.
All right. Thoughts on decreasing in magnitude? You don't think so? All right. Gribben says he thinks it doesn't decrease in magnitude. Anyone think they know?
I disagree.
All right, I'm gonna put a solid question mark on that one for myself. I feel like the limit might help me decide that. So I'm gonna jump down to the limit and kind of play around with this limit to see if I can feels a little more mathematical. Feels like I might be able to put a little more math in there. But factorial, he's looking a little unfriendly. So can someone give me a kind of large number? 8, sure. All right. Yeah.
What is the
Naked.
explanation for? What is that?
Let's talk about it. It's called factorial.
Please tell me why I like to go over.
What face are you making? Oh. All right, so factorial, you might have learned it back in like algebra 2, maybe, when you were talking about permutation combinations. So I'm going to try to compare the size of something factorial and 2 to the something to maybe see if I can see where this limit is going, which one's growing faster. So what factorial does is it takes a number and it counts backwards until you, that's not how you count backwards. All right, I didn't skip any numbers, right? All right, I was going to try to stop talking while I was writing. So you multiply down. Now, we haven't done a lot of these because they're not really great for like graphing functions because their only inputs, at least for us, are going to be whole numbers. Fun fact, 0 factorial is 1 by definition. It has to be to make math work. But we're going to work with stuff like maybe 8 factorial. So 8 times 7 times 6 times 5, 1, 2, 3, 2, 1. Does anyone have a calculator?
Yeah,
40,320. Wow, read my mind. Great. All right, 2 to the 8th. That's what does 2 to the 8th mean? All right, but that means just 2's multiplied, right? How many? 1, 2, 3, 4, 5, 6, 7, 8. All right, what was that? 256?
Yeah.
All right, so pretty clear which one's bigger here, right? Do you think this one will remain bigger the bigger number I plug in? So if I plug in like 9 where that 8 is, or 10 where that 8 is, why do you think it'll remain bigger?
Because that's one number.
All right. So I'd be multiplying the same number of things each time. So 10 factorial and 2 to the 10th, they both have 10 things in them. But what's happening to the factorial ones? They're all getting bigger and bigger and bigger. This one's just rolling with the 2's. So I think that factorial grows faster than this exponential does. So let's roll back to our limit. Where do we think this limit is going? Why do I care? All right, so what could my conclusion be? All right, with this set of directions, do I have to do anything else? It says determine the absolute or conditional convergence or divergence for each series. No, there are not different types of divergence. So if we diverge, we're just done. So let's look. The next one is going to be more so what you would do to follow these directions. Because the limit doesn't equal 0. Mm-hmm. All right. This one looks weird. He looks different. Why does he look different? Is it? All right, let's plug in some stuff. All right. Let's start with what? Hold on. Before, let's not fight. Let's plug in some terms. Let's get some facts to fight about. So, what number should I plug in first? 1. It's here. So that would give me cosine of pi. All right, get your unit circles up. What's cosine of pi? All right. Then I would plug in 2. What's cosine of 2 pi?
1.
All right. Then I would plug in 3. What's cosine of 3 pi? Yeah, it's at the same place as pi is. All right. All right. What's cosine of 4 pi?
1.
Wow.
Do you only have to use the numerator when you're figuring out alternative?
Usually they put the alternator in the numerator. I could put it in the denominator, but usually they'll hide it there. What sign do you think the next one would have?
Negative.
All right. So let's talk. Do the terms alternate?
Yes.
All right. What's the next thing?
Yes.
All right. Do they decrease in magnitude? If we want, we could list them out without the positives and negatives. So 1 over the square root of 1, 1 over the square root of 2. Denominators are getting bigger. All right. The limit as n approaches infinity. Disregard the alternator. So in this case, disregard the cosine of pi, whatever, pi n. Does that go where it needs to go? Emery says yes, very convincingly. Is anyone else convinced? Cool. Yep, thank you for that number. So let's see if we can write the sentence. Bonus points if you don't have to flip to the front of the notes.
This series.
This series. Terms. Okay, this is an important point. the thing that does these things is the terms and not the series. So the series is a number. It has a sum. The thing that is alternating, decreasing in magnitude and has a limit of 0 is the terms. Because I'm lazy.
So math, we don't have it.
Because every word means something. So if I don't need a word, I usually leave it out. Since the terms alternate, whole word. Decrease. Oh no. No.
What?
Finish the sentence. On your paper, finish your sentence. Oh no!
That was a whole range of emotion.
Because I have to there's so many things that have to happen. My Google Meet's gonna shut down. Sorry, Google Meet. It's probably already done. So that means I have to merge 2 videos together. It'll take forever to upload.
Was I the only person to ever use Google Meet?
What?
Was I the only person?
No, I think there was one other person. I think you were the only one that talked. Oh, wait. We're still up. I'm not presenting now? All right. Let's see if that works. Ooh, that probably means that my whole breakdown was caught on video. All right, help me out. Yes. So the in magnitude is important. This is a good question. Rashad asked, do I need to write in magnitude or just decrease? Think this is a negative term, then goes to a positive term. So if you don't write in magnitude, it's actually a false statement because this is going up, then down, then up. There. And what else? Alternating science test known as ACT. All right. So I'm going to actually use a bunch of space down here because we're kind of now only about halfway done. We know that this series converges, but now we have follow-up questions. Do I converge absolutely or do I converge conditionally? The only reason I'm doing this, to be clear, is because the directions are asking me. So if I just asked you if this series converged, cool, I've got my sentence, I'm done. Because it's asking me further questions, then I'm going to keep going. So now I'm going to consider the series where I drop the alternator. So the absolute value of that series, just drop that alternator off. So I'm looking at 1 over the square root of n. Now I've got all of my other tools that we've done so far. I need to figure out what type of series this is, what type of series test I want to do. Does anyone have any ideas? A P series? How do you know that? That P stands for power. What power would you use? Oh, cool. So, all right. Cool. So the P series. This freezes again, I swear. It doesn't do anything. No. You have, wait, what? Why? Why does it do this to me? All right, so let's talk through this and I'll write in a second. So what's P? 1/2, which is? So this does what? Diverges. So let's answer the original question and I will finish this in a second. What does the original series with the alternator do? Conditionally converges. So I'll write that up in a second.
Would you have to just put conditionally in front of convergence?
You can. I usually write it just as a last step of like, oh, wait, mouse is moving. Nope. What the heck? And I just got a new computer and now it's doing this. Like, what?
Oh, no.
Oh, look. Put me on live.
I'm sorry. As soon as I remember I can do it.
When you have a breakdown while you're doing notes. All right, so let me finish up this question, then I'm gonna have you guys do some stuff. If this goes down again, I'm just gonna stop. All right, so this is a P series. We are refocusing. P is 1/2, which is less than 1, which means this series diverges. So, if you write P series right here, that's fine. Kind of just skipping a step. All right, so my final conclusion is my original series, which I'll rewrite just to make sure my conclusion's really, really clear. What was that? Cosine of pi over this guy. So the original guy conditionally converges. All right, or converges conditionally.
Can we just add that on to like the end of the sentence?
Yeah, so you're kind of just answering your final question.
So how do we find the absolute value of it?
Essentially just drop the alternator because everything but the alternator is positive. You have just a regular numerator, so you have just 1, and then the square root of n on the bottom is always going to be positive. So the only thing that's doing anything with signs is your alternator, so you can really just drop that. All right, the last question we're going to do before break has to do with like, what if I'm not really sure what's happening? Now, this last question will probably not happen a lot. So if you're doing a question like this set of directions, the determine absolute or conditional, it's probably going to look like this middle one. This last one is like, what the heck if things go weird? So what I would like you to do, and then we're going to talk about what to do actually, is I would like you to write out the first 6 terms of this series. So I want you to just list out, kind of like we did here. I did 4 terms here. I want you to list me 6 terms because I am not sure what this exponent does. So here, this is n times n plus 1 all over 2. Really what we're trying to figure out is the question that Nate just kind of tried to answer. Do we think this thing alternates or not? So find me first 6 terms. Try to answer the question. Does this series through its terms alternate? Exactly. I remember what? My skull? No, I can't look at my ears. I feel like those are relatively similar. I don't even know what to, yeah, you are. I don't even know what to tell them. Like, what are you telling me?
So this negative one, you know how you're focused, right?
But since, okay, so if
I can touch my tongue to my nose.
take out the like alternator or whatever, then it diverges.
I've also been told my elbow's been bad.
Oh my God. So it only converges when it has the alternator.
I love stupid human.
Oh, yes, every time.
My dolphin.
That was like let's do it for like
Oh, I've never understood that one. I just need to explain to me. All right, anyone got 6 terms for me?
I got one.
You got one?
I think I have. Actually, I think I have.
All right. What's the first one?
Negative 1/3.
I'm gonna trust you guys. I don't have my notes in front of me.
It's a negative 1.
Negative 1/9.
Anyone get another one? 1/20. So positive.
1/7.
Okay. Anyone get another one? So you'd be plugging in what? Positive? It is weird. Getting wild. All right.
Negative
I do know the powers. And was the next one positive or negative?
Negative.
And this is 729 if you didn't know your powers are 3. All right. What do you think the next term would be?
positive.
All right. So my question is this alternating? We're not allowed to say kind of.
What if you combine the
Can't really do that. So the answer to is this alternating, though we would like it to be yes, is really no. Alternating series tests, you need to alternate back and forth with your signs, not kind of have a pattern. And we're not really like, though we think this pattern happens forever and ever, we haven't really proved that this pattern happens forever and ever. So this series is not an alternating series, which means I can't use alternating series tests on it. But that top term is a little weird. So here, to use a football sports analogy, we're going to throw a Hail Mary pass. And we are going to say, I think that if I disregard this alternator, I'm going to try to find a conclusion. This will not happen a lot, but here's just like, I have lost some ideas. Let's try it. We are just going to consider the series without the kind of alternator in it. So we're assuming we're absolute valuing this series. So I'm going to look at the absolute value of this series just to be really clear about what I'm doing. Because if I can say that this converges, then I know the series with the semi-alternator in it converges. All right. Do you agree with me that putting absolute value bars on that guy is just going to like crush out the numerator? What are the only 2 options coming out of this top guy? 1 and -1. The absolute value of both of those is 1. So I'm going to say this is 1/3 to the n. That looks a lot nicer to look at. Anyone think they know what type of series that might be? Ooh, geometric. That's interesting. That's usually something to the n, right? What would I put to the n? Ooh, okay. What do we normally call that 1/3? The ratio. We usually look at the absolute value of that, right?
Yeah. So it's
Why do I?
because it's less than 1, so that means it's
And that's by geometric. Now let's take a. That's not how you spell geometric. Now let's take a step back at this. So remember that being absolutely convergent, meaning not needing the sign changes, is stronger than just being convergent. Something being absolutely convergent, well, a word in there is convergent. So if I can show that the absolute value of this converges, I do get the conclusion that the original guy with this weird old exponent on this -1 converges. There's not really a test there because we're using the geometric with this absolute converges, but I would say this is not going to happen very often. This is just like a very special type of problem where you could, if you had an alternating series and you were like, maybe, I'm not sure, you could go for it. Yeah, Michaela. Here to here. So this option here, no matter what n I plug in, this -1 to this exponent is either going to be +1 or -1, depending on whether this exponent ends up even or odd. So if I take these absolute value bars, that absolute value of 1 is 1, absolute value of -1 is 1, so that would just be 1 on the top. That was a dramatic scroll. I didn't mean to do that. So really the conclusion for you here is, let's say you were looking at one of these questions where it said determine absolute or conditional convergence, and you were like, I think the absolute value of that will converge. You could miss out on like writing this sentence here. If you were like, I think the absolute value converges, you might not have to do it in 2 steps. You could just do it in 1. But kind of just a cool thing to do if you don't know. Really, moral of the story, if you don't know what something's doing, list out some terms. All right, so we use a break. All right, when we come back, we are going to talk about if I stop my series somewhere, how far off is that series sum, like that partial sum, from my actual sum? And can I find a bound for that error? We'll talk about that, and then I'll prove 2 different numbers are equal to each other. So, take 4. What?
Yeah, wheels or doors? Do you think there's more wheels in the world or doors?
What?
It's wheels. Wheels.
That's wheels.
Do you know it?
It's wheels.
No.
We're just assuming, but it's
That's
wheels.
If you count switches as doors, because technically.
What?
You do not count switches as
Wait, how would it possibly be wheels?
because there's wheels on chairs,
All those
wheels on
cars,
cars, like
But every car that has wheels also has doors.
Yeah, but it's like
Wheels. There's like 2 doors. We're just all 4 wheels.
wheels.
We got
In office buildings, the chairs have wheels. The office
There's
chairs,
only like 1 door.
and like skyscrapers have wheels.
Wait, what? Skyscrapers have wheels? Explain that statement.
No, like the office chairs, and like it's like all those big business buildings, skyscrapers.
It's doors though.
No, it's
Wait, why are you asking this question?
Because like everyone's been talking about
It's like a thing.
Everyone's been talking about wheels or doors.
Yeah.
You know what the hot topic was a few years ago? If a polar bear and a hippopotamus got in a fight, who would win?
Definitely polar bear.
Hippopotamus.
Well,
Well,
it depends. Is it in the
snow or the water?
Yeah, it
Just
depends on
any
where they are.
random fight.
I think it depends on the location.
Street and just like.
But no one goes to Ann Arbor.
I mean, there's a zoo. We could just like put them in this.
Polar bears are my favorite. Well, no. They're my second. My first favorite.
Oh, also everyone spread the word about the 100-day giveaway, and also make Kenley and Sarah sell it better next morning on the announcements. Kenley and Sarah, if you end up, so it's kind of a collection of things. So there was a $50 gift card in it, and then there's some stickers and some glow sticks and some pencils and a little graduation rubber ducky and a stress ball. Yeah, so it added up to 100 things. I mean, $50 is 50, but.
Isn't that the best prize?
One is a TV, so there's a mini fridge towards the end. Thank you, PTSA. We also ordered a lot of the small stuff because our budget's really small. Some candy in there. A little water bottle that's blue and yellow.
Has Kaylee picked it up yet?
No. Does she even know? I emailed her. If you know Kaylee, tell her to come pick her up. New winner tomorrow.
I love that.
I'm excited about it. I just need people to spread the word because they didn't seem very excited about it on announcements. Oh, yes.
Did you enter yourself in it?
No, any senior.
They just randomly choose.
They being me and Nishadi, yeah.
Wait, who won the 100-day?
Kaylee Moranton today.
Yeah. So what's today?
It's like a $50 gift card and then a collection of smaller stuff. It all fits in a bag.
Add up to 100.
Mhm. I can list it out if you would like, but I have to go to my filing cabinet. Surprise was locked in there. Yeah, happy 100 days of graduation, everyone. Kaylee Moranton. Stay tuned for tomorrow's winner.
Where is it now?
On the morning announcements, and then we're going to put signs outside the door. Mondays are going to be especially exciting because there will be 3 winners for Saturday, Sunday, and Monday.
Oh, that's fun.
No, because there's more than 100 seniors. We got about a 1 in 3, 1 in 4 shot of winning. Probably give it to them at grad rehearsal. All right, we ready?
Yeah.
We got more stuff to learn. All right, so one of the hardest things we learned this year is not this, but this is going to help prime our brains for it and also be useful. So one of the things about approximating that's interesting. So let's say I take this infinite series and about 6 terms in, I'm like, I'm tired. I would like to just add these 6 terms together and say, that's good enough. That's about what my sum is. So what we're going to try to figure out is if we stop after 6 terms or 1,000 terms or 2,000 terms, how far off are we from the actual sum? Now, we won't be able to actually answer that question because we don't really know how to find the sums of too many series, right? There's only 2 of them that we know how to find. Anyone remember the 2? Geometric, what's the formula for the? All right, telescoping. Telescoping, that's just the uncanceled stuff. Does anyone remember the formula for geometric? A over 1 minus R. Other than that, we won't actually be able to find the sum. So we're not actually going to be able to find what I can call 2 names, the remainder or the error. So I'm going to use those names pretty interchangeably. So think remainder is like, if I stop at a certain point, the remaining terms, how much are they together? Error, think of how far off I am from my sum. So what we're actually going to do is we're going to find what's called an upper bound for that error. So a number that's definitely bigger than that error is. You could think of that like if you were working in a factory, like a tolerance for your error. How much are you allowing yourself to be off? And I can be a little bit less than that. The cool part about alternating series is because of this behavior that they have, which I'm going to kind of draw and explain in a second, this error bound ends up being really easy to find. It is the absolute value of the first omitted term. Let's talk about what I mean by that. So let's say we got an alternating series. If we add up 0 terms, the sum is 0. Brilliant. If we add up the first term, let's pretend that one's positive. We get to this partial sum right here, S sub 1. So it's just me adding the first term. The next term, if we're alternating, would be smaller because we're decreasing in magnitude, and it would be negative. So we would subtract it, but we wouldn't go back quite all the way to 0. Then the next term would be smaller, and we'd move forward because it would be positive. Now, this kind of bebop in behavior would go back and forth, and right in the middle would be my sum. Now, notice that the distance that I'm off from this sum is definitely smaller than the length of that 4th term there. So here would be my error between my actual sum and my 3rd, and the 4th term is definitely bigger. Now, the benefit of this is the 4th term, if I have the terms of the series, is really easy to find. So while it looks like, hey, your error is like kind of a lot bigger than what the actual error is. Hi, how did it go? While it's kind of a lot bigger, it's a really easy error to find. So let's talk about this in context and see what we're doing. So let me write some stuff down. Am I interrupting your conversations? Got Nate with that joke. All right. So my partial sum here, my approximate sum is I take the first however many terms and I add them up. So the idea here is we're not finding a like actual sum going all the way to infinity. We're approximating by taking the first however many until we get tired. Now, our error bound, we can notate a couple of ways. So the actual error here, I can write two ways. With a remainder that r sub n, if I had 6 terms, it would be r sub 6, the remainder of that, or my actual sum minus my 6 partial sum. So that's the actual remainder. So if I had a geometric series and I was actually able to take the real sum minus my approximate sum. What we're claiming, and that we've kind of decided, is that this is definitely less than the next term up. So if I had 6 terms and I had the remainder, it's definitely less than the 7th term. So I'm going to show you 2 different ways I can ask you about this, and kind of 2 different ways we could approach this sort of question.
Would the 6 be like the end?
Mm-hmm. Yeah. So let's do this with actually a concrete number of terms. So here we've got this series. We're alternating, yes. Let's check actually those 3 conditions. I know alternating is 1. That was right. What was the other one? Do you think this guy is decreasing in magnitude? 1 over n factorial? Yeah, it's decreasing pretty darn quickly. So decreasing in magnitude, yes. What was the last thing? Is the limit as n approaches infinity 0 on that one? Yeah, so this is a convergent alternating series. Cool. So I can use alternating series error bound. So what we're going to do is we're going to find S sub 4, which is the 4th partial sum. We're going to add up the first 4 terms. All right, can you just for me plug in 1, because here, and figure out whether this first term is going to be positive or negative.
Negative. I think it's negative. No, it's positive. Oh.
What's that exponent going to be?
Squared.
Squared. All right. So first term is going to be 1 because I've got positive 1 times 1 over 1 factorial. Next one, since we're claiming this is alternating, is going to be minus 1 over 2 factorial. Anyone know what 2 factorial is? Thrilling. All right. Next one, 1 over 3 factorial. Positive because we're alternating. Anyone know what 3 factorial is? 4 factorial. What's 4 factorial? Cool. Can someone with a calculator add those up? Because I don't know where I put my notes. I'm just winging it right now. I think it's like 0.65. What's that? That's what I told my other class. Ooh, bless you. All right. So this is if I add the first 4 terms together, my 4th partial sum. So what I would like to show in the next question, and this is phrased very much like the AP test would phrase this type of question, is we're going to use the alternating series error bound to show that this number is different from the actual sum by less than 1 over 100. Now, 1 over 100 is just the number they're throwing out there for us to compare to. You're going to notice something about that number, and we'll kind of talk about it at the end. So you can write this again one of 2 ways. I'm just throwing all of the notation out at you. I could call this the remainder of the 4 terms, or I could call this S minus S sub 4. I'm actually probably partial to this notation of the actual sum minus my 4th partial sum personally, but it's kind of a personal decision there. What you need of them. What we do need is what definitely less than. So our error bound. What is this definitely less than? Which term? The first omitted term, which we did the first term, the second term, the third term, the 4th term. So the 5th term, which would be 1 over 5 factorial, right? What is 5 factorial? All right. What do we notice? Is that less than 1 over 100? All right. We're going to observe that for our reader. And you could throw a by alternating series error bound on there if you wanted to be really aggressive. All right. One thing that usually happens, I'm not going to put a guarantee out there, but just usually I've seen it happen. Generally, this number is about the same size as this one. The AP test is kind of trying to push you in the right direction. That's a pattern I've noticed, but can't prove because I don't write the AP test. But generally, I see those two numbers are about the same size, if that helps. So what does that mean? That means that my sum is definitely between two numbers, which makes this a little bit interesting. So I know it's definitely between my partial sum, so my 0.625, if I take that away. So if I take away the 1 over 1/20th. Oh, this is where I wish I had my notes. And my 0.625, and if I add that 1 over 1/20th. So I know that my partial sum has to be between those two. Which I would love to give you those two numbers, so I'm finding my notes right now. So that is 0.616 and 0.633. So the bound for my error is 1 over 120. So I know that I'm definitely off by less than that. I don't know how much less because I can't find the sum of this series personally, but we're definitely less than that. So do you think the sum could be 0.7? No, it's too far away. All right, so one way I could ask about this. The other way I could ask about this, I might ask you, how many terms do I need to be within a certain amount of error? This one I like better. There's two ways to do this. So I'm going to show you the lazy way first, and then like the more mathy algebraic way. I like the lazy way better. So since our first omitted term is our error bound, if we're looking for how many terms do I need to approximate by less than this error, we could just start listing terms and find the one that is less than this. Call that the first omitted terms and say you need to add up the ones before. So what I'm going to do, since this doesn't seem to be too darn small if we're talking about n to the fourth, I'm just going to start listing terms. So first term, let's try this again. Is the first term of this series positive or negative? Good, positive. And would it be positive 1? All right, let's see if we can take things to the fourth power. I think this series is alternating. So the next one would be negative. And what is 2 to the fourth power? 16. Thank you for not saying 8. All right, the next term would be positive. 1 over what? 81, 3 to the fourth. All right, now it gets spicy. All right. Next one. Negative 1 over 256. Now I haven't been asking you yet because I wasn't convinced it was. Are any of these smaller than 1 over 1,000? Not yet. So let's keep going. Next one. We need 5 to the fourth. Equivalent 5 squared times 5 squared. So if you want to do 25 times 25. Okay. 625 is the winner. Are we small enough yet?
No.
6 to the fourth. Small enough?
Yeah.
All right, so let's talk about conclusions. So our 1 over 1296 is smaller than 1 over 1,000. Now, that was the absolute value of our sixth term, right? Did I count that right? 1, 2, 3, 4, 5, 6. So that's definitely bigger than the remainder for the fifth partial sum. So essentially what you would want to do is you're going to say, I'm going to cut this off here. This is my next term up. So the answer to my question is 5 terms. Now, you may be sitting there asking yourself, well, what if it's not 5 terms? What if it's 50 terms? I don't want to list out 50 terms. That does not sound like fun. So there is a way to do this with algebra, per usual. I also love algebra. What you would do is essentially set up a generic n+1 term. So I'd take my series term here, disregard the alternator, because for this guy, we're absolute valuing him. So I'm looking at 1 over n to the 4th, and I would plug in n+1 since I'm looking for the next term up, and I would set that less than 1 over 1,000. So you would kind of plug in n+1, set it less than what you would want, and then you're solving this inequality. Now, it's a little harder, especially with, we've learned a lot of math. Our solving skills might not be the strongest, but let's see if we can. I'm going to effectively cross multiply. So I'm going to multiply 1,000 over and multiply the n+1 to the 4th over. The inequality will stay the same since both of the things I'm multiplying are positive. Then I would get rid of that 4th root, or sorry, that 4th power by 4th rooting. I'm going to switch sides too. I wish it was. 3rd root would be the decimal. And then I would subtract 1. I have this on my, I did this on my calculator, so I'm just going to give you the decimal, and then we'll talk about how we would do the answer. This would be 4.623. You would always want to round this up. So even if it weren't 4.6, if it's 4.001, you need to round this up. So you would want at least 5 terms. If you had something where you needed to like 4th root 1,000, absolutely. There's one on your problem set where you have multiple choices, so you could plug in those numbers if you didn't want to like do the algebra. But if you look at those answer choices, they're like 3,333, 1,111. So those are really big. Wouldn't want to list that many terms. Sean?
It was like 4.4 with 4.
5. You always want to round up.
So like even if I was like 4.
0, 0, 1, 5 terms. Mm-hmm.
Okay.
All right. This last part, you do not need to write down. We'll talk about the takeaways, but I am going to show you a very, very cool thing that may break our brains, and is the result of one of our favorite mathematicians, this bad boy. So Riemann actually has some really cool conclusions in math. This is Riemann of rectangle fame. So Riemann sums, also of Riemann hypothesis fame. So what he says is this very cool theorem, the proof of which is way, way, way beyond the scope of this class. It has to do with absolutely versus conditionally convergent series. So what his theorem says is if a series is absolutely convergent, so if I take the absolute value of it, every rearrangement, so if I take the terms and move them to a different order, any way I do that, I'm going to get the same sum. That's fine. That makes sense. Creepy part. I can take any series that's conditionally convergent, I can rearrange the terms in a different way, and I can get not 2 different sums, any sum. I can rearrange the terms. I can get 5. I can get 4. I can get pi. I can get natural log of 2. I can make it diverge. So what I'm going to do as one example is I'm going to take this series and I'm going to make it equal something else. You're going to make sure I don't do anything algebraically wrong. Are you ready? All right. Kind of. All right. This series, we named him today. Who is this? This is the alternating harmonic. So we know it converged by the alternating series test, but is conditionally convergent because the harmonic diverges. So what I'm going to do is in my first step, I'm just going to rearrange the terms into a different order. So I'm doing this order not because I am clever, but because someone else was, and I know it works. If you think it's because of me, sure, keep thinking that. All right, so I'm going to take the 1 and the minus a half. I'm going to take them. I'm going to skip the 3rd, and I'm going to pull the minus a 4th. All right, I'm going to keep now the third here. Now I'm going to start asking you about some terms to help us rearrange. So I'd like to pull the one that has a 6th next. Would that term be positive or negative? Why are you guys saying negative? Looks like all the evens are negative. So I'm going to pull the minus 1/6. I'm also going to pull the 1/8, positive or negative. All right. Then I'm going to do the 1/5. That's positive, right? That looks like the next one. And then I'm going to pull the minus a 10th and minus a 12th. All right. So before I keep going, do you think if I pull the numbers this way, do you think I'll still hit all of the numbers? No. Which ones am I going to leave out? Well, that one will come later, right? I'm doing 1, 3, 5, then it'll be 7, 9. Yeah, it's a pattern. I'm just rearranging the numbers. So do you think I'll eventually hit 1 through infinity at the bottom? Yeah. So I just rearranged them, and I haven't changed any of the signs, right? All right. So now what I'm going to do, I'm going to put some parentheses. Why? Because I would like to. If I put parentheses here, that doesn't like change the value of this, right? All right. How about here? Did I change the value at all? All right. And how about here? We still good? All right. I'm going to do what's inside those parentheses. I'm just going to subtract. So what's 1 minus a half? All right. Keeping the 4th. This one really got my second block. So take a minute to think before you say something. What is a 3rd minus a 6th? All right, so this guy here is the 2/6 I think you're talking about, Sean. We subtract a 6. You guys agree with 1/6? Nice. It took my second block a lot longer than that. All right. Keep minus an 8. What about the 1/5 minus 1/10? Positive, right? All right, so still legal. Haven't changed the value, right? Is this starting to look kind of familiar? These are all even. Thoughts on taking a 1/2 out? All right, so if I factor a 1/2 out, 1/2 times what gets me 1/2? All right, 1/2 times what gives me 1/4? 1/2 times what gets me 1/6? Next one. Oh, it does look like the first thing, right? What was the first thing equal to? So this equals 1/2 natural log of 2. So I have just proved natural log of 2. 1/2 natural log of 2. So I can rearrange this. The cool part of this theorem, which you can argue with me all day, you'll have to take it up with Riemann, is not only, if I were clever enough, not only could I make it equal this, I could make it equal any number I want. Any number in the entire world. I could even make it diverge based on how I rearrange it. So what is your takeaway from this? If I rearrange the terms of a convergent and absolutely convergent series, no matter how I rearrange it, it's going to remain the same sum. So I can't do this if it absolutely converges. If it conditionally converges, I can make any number I want. I'd have to find the phrasing of an AP question. One isn't coming to mind because I doubt this comes up very often. I think it's mostly just a really cool thing. I will search and see if I can find an example of how that would come up. All right, so instead of a notes check today, I want you to very purposefully look at your problem set. So going back to the beginning of these notes. So find your problem set while I'm scrolling back up here. Back at the beginning of these notes, I said this test is relatively easy to do, but also relatively easy to find.
I don't know if you saw my top back there. Kaylee came and picked up.
Oh, good. Was it? Wait, did I open it or were my keys back there? Okay, good. I realized that as soon as I walked downstairs yesterday.
I went home.
Was she excited?
Oh, she's very excited.
Oh, good. I've been telling them to spread the word.
She like came to the worker, you know, and she said like I'm supposed to like I won something and I'm supposed to be picking up like something like, for 100 days. I was like, so then she was talking to like Nikki and Debbie, and when I came, and so I stood at the door and I was like, you won 100 things, and I like read it off or whatever, and she was like, oh my gosh, and like Nikki and Debbie were like. What? And they were like, why is this like not being promoted? I was like, well, it is.
Trying.
And she was like, and they were like, no. Like, at any point, is it going to be listed like what they're winning? Because that's the fun part. And I was like, I'll talk to Mel. We got to figure out a way.
Maybe
to,
we can ask one of the winners to do like an unboxing on the morning announcements,
Okay.
or we could just have them read one.
Gotcha.
Put your brain into it. We could. That would be. Oh yeah, let's take a picture of one of them.
Okay.
I'll do it during 8 o'clock.
Okay.
And yeah.
Got it.
Okay. I can hand those back out. All right. So here's what I want you to do before the end of class today. So we have about a little over 10 minutes. You have a bare minimum and you have a little bit more. So all of the alternating series stuff. There are 2 in that's not a 9. Numbers 1 through 14. Can you very quickly for me? I want you to scan through your problems. And I want to decide as a group which are the 2 that we should be doing alternating series tests for. I wouldn't use it on number 1 personally. I would do geometric for 1. 7 I definitely agree with. All right, what's the other one? 11 I definitely agree with. So those are the 2. And a reminder, that's mostly just this sentence. So practice with that, confirm your conclusions. Now, you may be able to use this test on some things that are geometric. It may work, and that's fine. So like number 1, it probably does work with number 1, to be quite honest. You just might have a different test in mind. As you're working through your problem set, the ones you want to avoid if you're getting a little bit more than those 2 done, I will tell you number 2, 12, 13, and 14, save those for next class. We have not learned those tests yet. What did I say? Oh, I was reading the 2s in number 10. Excuse me. There's a lot of 2s there. Sorry. 10, 12, 13, 14. Those are called either ratio or root tests. Those are the 2 tests we have left to learn. All of the rest of the ones from 1 through 14 you should be able to do. Also, if you want some of the extension questions that we did today, that error bound, that stuff like that, those are 17 through 19. I would like you to try by the end of today to get at least the 2 that we talked about from the beginning done there. As you guys are working, there has been a request for me to de-hoard my papers, so I will do that. Some of you guys have some notes checks to do. There you go. Like this. So this is always
1 to 14, 2 from 1 to 14. No, that's more. That's more. 2 But she didn't say that. She just said 2 from 1 to 14.
yes. So this
2
does
from number 1 to
require
14.
yeah, that's totally fine. We will all have to sub. Yeah, so that's unlike
So like, I know like it's
getting.
Yeah, if you change the definition.
Yeah.
Can't change the definition.
Yeah.
Every definition.
All right, so everyone around some notes check. These are old ones.
I don't know. It's a definition. All definitions are related.
Yes, ma'am.
You guys think you're understanding, like,
He's gonna open.
absolutely.
It's programming.
Only have to do that.
Like, why not just fly?
What's it called? And then,
I know.
This unit.
There's no way that-
it's all about arguments.
Where's your problem?
He's on my house. I wrote them down.
So one, one third.
Why is it so nervous?
One third, one fourth,
Like,
one
serious.
negative one.
Yeah.
Yeah, we ate this one up though.
That's what school is.
Oh, I know.
For the denominator, you probably will, so I was just
I don't
thinking
know.
it as
I really like watch hockey
like.
games. It's not that.
Yeah, I feel like personally, like, no, that's or and like to compare them to what we
Sorry that I did, yes.
Divide, or you multiply it by the reciprocal. We don't have to reduce and like, if it's just that's by itself, we have to like.
No, only time you would have to divide it by explicitly ask you here if you have one. No, yeah.
It's not bad. Is that a new song or is that a new song?
I haven't heard of TikTok before. I just hardly I couldn't stand your room, bro. Say. Playing video games at 100-degree weapons.
So highest there over 1/4, that's not really enough to go over.
We're not absorb this one.
Oh, wait, no, it's plugged in.
High over 2 is rarely.
The stuff you could leave out. No, not like in the board, like, wow,
What?
like, I'm over it, but this is the necessary.
That's what I said. What? That's amazing.
I want to see the full term in there.
And then
Drop
five,
if you don't want it.
five, one,
And then it's diverted.
You're like. Yeah. You walk there, you're like.
It's bumper or 7 and 8.
I don't know, Sean. I didn't know this. I was right on this one.
What's 5 over 7 now? Yeah. All I couldn't figure out the
I'm a snap like I did to Sean, bro.
Wait, then I have to.
So you gotta multiply. Oh, I didn't even write. Wait, I didn't even write.
These notes.
Oh, is that-
Writing this. How do you know what
I did about it.
I forgot the bell rings at 3.
So you don't have to do like the limit and the sum. We're being really super.
My favorite.
Okay, why did I write it? That's so sad. That's that.
Oh, it's over here.
You don't have to. Oh my God. All right, before we leave, we got about a minute and a half-ish. Just to be very, very clear, I'm going to try to build in some problem set time next class because the notes are relatively short. You will like the tests for next time, especially ratio tests. If you haven't been paying attention all unit, ratio test is the most important test that we will be learning. You'll like it. There's a lot of canceling, very fun. A lot to do with factorials. Root test, kind of an add-on, very similar conclusions. But I believe those are no staple notes. So we will try to do those as quick as possible, work on the problem set. That problem set is due next week on Tuesday. So please, please, please start working. This assessment next week on Thursday. So just updating. If you have any questions, feel free to email, pictures, whatever. We have less than a minute. So hopefully you got your 2 questions done. Bring that problem set to class next time, and we will finish up with convergence divergence tests. April 11th, I believe, is the Monday. Hi.
So is that, like, I'm totally done.
Yeah, 9 halves would work.
Okay.
So you can always do power over root, essentially. So the 9th on the top, and then the square root, the 2 on the bottom. So if it had been like, this, you can do power over your root.
Oh, okay. So I could do 9 over 2.
All right, those of you that owe me quizzes, get them done.
I think I did this right.
Yes.
All right, cool.
Bye, everyone. Yeah. Right now? Perfect.
Can I do that too?
Yeah. I get a lot of emails.